Okay, so to begin with, what I want you to do is to write down all of the points on this circle. I'm going to pause. Okay, we're back. Here we go. I want you to tell me, what did you have right there? Pi over 6. Good. And that's 1/6 pi. And I hope you didn't use this one for your next one. You probably should have gone to this one. 2/6 pi. Now, granted, that is reduced to pi over 3, but 2/6 pi is going to be better because then I can go 3/6 pi, 4/6 pi, 5/6 pi. 6/6 pi is the same as pi, and I'm going to go to 7/6 pi right away before I forget what to do. Man, it's really hard to say 7/6 pi and write it right. 8/6 pi, 9/6 pi, 10/6 pi, 11/6 pi, and 12/6 pi would be 2 pi. All right. Then the other ones that I didn't do, I skipped because they're different. Pi over 4. 2 pi over 4 would be here. Notice it's the same exact thing. 3 pi over 4. 4 pi over 4 would be there, which is the same thing. 4 pi over 4. 5 pi over 4. And then 6 pi over 4 is the same as that one. 7 pi over 4. And 8 pi over 4 would be the same as 2 pi. And the last thing I asked you to do is put out these points. I did that while you couldn't hear at home. This is at over 1 and up 0. This one's at over 0 and up 1. This one's at over -1 and up 0. And the last one is right there at over 0 and down 1. Okay. Yep, -1. So, if I asked you to tell me where 270 was, hopefully that's one that you have memorized. Get the 270 goes all the way around to there. So 270 is the same as 9 pi over 6, which is the same as, if I reduce it, 3 pi over 2. Okay? Some other biggies that are going to come up a lot. 180, of course, and that's this one. That's 180 goes to there. Okay? Another one that's pretty common is 3 pi over 4, and that's to right there. That's also known as 135 degrees. All right. So, just wanted to make sure you remembered those because you're going to see a lot of these. All right. If I have that little saying, all students take calc, that reminds me where things are positive and where things are negative and stuff. So, why can't I make this stop being highlighted? I don't get that. There, okay. If I asked where is cosine and tangent both negative, I'd like you to draw one of these, or you've got one on your page. Just put your pencil in the right quadrant where you think I should draw my triangle if cosine and tangent are both negative. There's only one quadrant that could work. Okay, so cosine being negative means it can't be here, and it can't be here, because cosine's only negative in the other two. And tangent being negative means it can't be here. So I hope you were putting your pencil in this quadrant. Raise your hand if you had that right. Okay, good. Then, if I was going to actually ask you to draw one, the common degrees in here, this would be 135 degrees. What would this one have been? Sets of 30, right? 120. How about this one? If it's sets of 30, it's 30 away from 180, 150. Good. All right, I'd like you to use the 150. And the reason I want you to do that is I want you to figure out what is cosine of 150 degrees. A lot of the problems are just deceptively simple. It just seems like, oh, well, that seems pretty easy. I mean, as long as you know your triangles, and you can draw your triangles, it is pretty easy. So cosine of 150. All right, so here's 150. Drop straight down to draw the triangle. You cannot do it a different way. Then theta's here, and that's called the reference angle. So I'm not really going to be doing cosine of 150, am I? I'm going to be doing cosine of 30, because it's the same answer. Except one thing is different. You'll probably have a negative in your answer. Get what I'm saying? If I did cosine of 30, then the answer would be the same, except for a negative sign. Because if I was doing cosine of 30, that'd be over here, and all the sides would be positive. Are all these sides over here positive? No, they're not. This one's positive, and it's, by the way, if it's 30 degrees here, then this is a 1 and a 2 and a square root of 3, right? Then which one's negative? That one is. Yes?
If you don't specify, should we assume that it's the unit circle? Or is it
Actually, you don't need to assume it's the unit circle unless they specify that it is. Okay, because these are a lot easier if you can just leave it as 1, 2, and square root of 3. Because see, if this actually was the unit circle, I'd have to take all these and divide by 2 to make it work. And it would still work, but it's harder. It'll either tell you or it won't tell you, and if it doesn't tell you, don't assume that it is. All right. So, I guess, what is the final answer for this thing? Cosine ka, adjacent over hypotenuse. Adjacent is negative square root of 3 over hypotenuse is 2. Negative root 3 over 2. Notice they gave me degrees, they wanted the sides. So there's the answer. Okay, moving on. What if sine of theta is negative 1/2? Now I'm giving you sides. I want to know the angle. All right, this is important. This is like the back side of the worksheet. A lot of you guys got stuck in there because you got lost. So this is R3 kind of stuff. You need a good example for your notes. This is a good example. This is probably worthy of putting a star next to it in your notes because this is important. Okay, so if sine's got to be negative, same as last time, you got to look for where can that be. Can that be here? No, because everything's positive here. So you better not draw a triangle there. Figure out where to draw the triangle. If all students take calc, then S is sine is positive here. It can't be here either. There's two places it could be. How do you pick? You don't. You do both because there's two answers. First find this one. It really doesn't matter which one's first, but sine's opposite over hypotenuse. Okay. There, and then that means that the theta must be 30 degrees, right? And a lot of kids will write down the answer of 30 and they'd be wrong. Because it is 30 here, but that's not how I get there. I have to get there by going 180 plus the 30, 210. Raise your hand if you had 210 on your paper. All right. Only a couple people knew that. Okay, yes. Yes, it does, but it won't affect this because we're doing sine, which doesn't involve the adjacent side. But you're right, I should have had a negative there. But you get, when you do sine, you do opposite and hypotenuse, so it's really only talking about these two. Yeah. All right. Yes, ma'am?
You said that hypotenuse can be negative.
The hypotenuse cannot be negative, ever. All right. So now back to what just happened there. Most people, I think, knew this was a 30 and thought the answer was probably 30. But remember, if you just did sine of 30, do you get the answer wouldn't be negative? Because sine of 30 is over here, and you wouldn't have any negative sides. The answer wouldn't be negative, so you can't say 30. So you got to think one step farther and say, okay, if this is 30, then what's this? And it's 180 plus 30, 210. Okay, so that's one of your answers. Now, would you please draw the other triangle over here? Yes, it's going to be strikingly similar, but it's not the same answer. It's going to be some answer that's close to 300 because it's way over here. Mr. S.
330.
Tell me how you do that. Is the 30 there? If the 30 had been here before, if this 30 was the central angle before, it's going to be 30 again. That'll save you time. If you know it's a 30 there, then it's a 60 here, then this has got to be 1, 2, square root of 3, and then look for negatives. That one's got to be negative. Okay, and then tell me how to finish this now.
Find how far it is.
Yeah, like you go all the way around here, but not 360. It's 360 minus how much? And therefore it's 330. Raise your hand if you get that. You understand that. Okay, good. All right. Let's do another one like that. Not that one. Let's do a different one. Just a second here. Save that other problem for later. Okay. So let's do if cosine of something is positive 1/2. There are two answers for that. It's just like the last problem. Figure out where you should draw your triangles, and you'll have two triangles, which is why there'll be two answers. Positive 1/2. All students take calc. Cosine's positive in those two quadrants, not over here. So it must be two triangles in those two quadrants. This one's, I don't know if it's 30, 60, or 90. I got to figure it out. Cosine adjacent over hypotenuse. And that must be square root of 3. And then this must be 30 up here. This must be 60. And is 60 the right answer? Yes, it is, because I'm in this quadrant. I don't need to go all the way around to get there. That's where I started the triangle in the first place. So it's from here to here, 60. All right. So then where's the other one? Well, the other one's got to be down here, and it's also got to have a 60-degree angle as the central angle. And that must be 30. And so then you got to look at the green sides here. I'm going to say that's 1, that's 2, and that's square root of 3, except it's negative. And then I'm trying to figure out what angle that is. Well, it's pretty much done now. I just got to say, what is it? 360 minus the 60 makes 300. Did you get that? Now, some of you might have said negative 60. And you're sort of right. That is sort of negative 60. But the directions, have fun. All right. So, kind of got lost there. 360 are my two answers. Is that it? I think that's it.
Why the answer is not negative 60?
Oh, yes, thank you. Why is the answer not negative 60? Okay, because the directions will say that they want the answer theta to be in between 0 and 360. Do you get how that precludes any negative answers? And it also precludes going around past 360 and saying, I want to say it's 360 plus 60 is 420. Well, it kind of is right, but they don't want you to keep doing that and get multiple answers. So they limit you to say the answers that are between 0 and 360. So you will never have negative answers for those. Yes, you'll have to know if they ask you what's the cosine of 480. That's just like saying, okay, do you know what you're doing? Because one trip around 360, that doesn't actually do anything. So I can subtract 360 from this and see what it really is. It's really 120. So they're really asking me cosine of 120 because these two angles are exactly the same as each other. Or not those two, sorry. These two angles are exactly the same as each other. Okay? All right. Moving on. What are the rest of the functions? I just want to remind you, we haven't done like cosecant or secant in a long time. If they give you this, they've given you two sides of a triangle. And you can say, all right, sine's opposite over hypotenuse, 1 over square root of 2. Is that even possible? Sure it is. What's the other side then? 1 square root of 2. So what's theta got to be? Theta must be 45. But is that what they asked for? No, they wanted all the other functions. What are the other functions? Well, there's sine. Just set it up in the big set of 6, you know. Sine, cosine, tangent, and what goes across from sine? Cosecant. And what goes across from cosine? Secant. And what goes across from tangent? Cotangent. All right, and sine is 1 over root 2, so cosecant must be just flip that, root 2 over 1. Cosine, well, now that I have all the sides, cosine is adjacent over hypotenuse, that over that, 1 over root 2, same exact answer. So this one will have the same exact answer as the one above it. And then the last one's tangent. Tangent's opposite over adjacent, which would be 1 over 1, which is 1. And flip that, it's still a 1. Remember those? All right, that should be the easy part. All right, now, this one, are they asking you for sides? Or are they asking you for the angle? Asking for the angle. We already just did a couple like that, so I don't think we need to do this again. You'd say sine's got to be negative, so you'd rule out a couple of the quadrants. Rule out that, rule out that. You'd draw 2 triangles like here and here, and you get your 2 answers. All right. Quadrantals. If they ask you tangent to 270, I hope you know where 270 is. It's like there. How can you draw a triangle? Can't. You'd normally take the point and drop a line straight down or straight up, and that wouldn't make a triangle. So you have to know this point. This point is at 0, -1, and therefore I know sine, cosine, and tangent. Sine's y. Remember that, sine y. So sine is -1. Cosine is 0. And what's tangent? Y over x, which is -1 over 0, which is undefined. So what's tangent 270? Undefined. Okay, tangent of theta is 0. On this one, they did not tell me the degrees. They told me the angle ratio. Wait, how is it 2 sides going to end up being dividing and getting 0? One of the sides must be 0. How can a triangle have a side length of 0? Oh, it must not be one of those triangles. Do you get what I'm saying? All right, so it must be one of these kind of things. It must be like, maybe it's here. Well, how would I test and see if it's one of those? Well, I check it and I say this is at -1, 0. And I say what's tangent of that? Tangent's opposite over, no, tangent is y over x. That's 0 over -1, and that would be 0. So this is one of my answers, is 180. Or if they wanted it in radians, I'd say pi. The other answer, I'm guessing, has anybody checked it? Is it this one? I think it's that one. And that would be at 1, 0. And the tangent is, again, y over x. 0 over 1 is 0, so that would work. So 0 degrees or 180. All right. Question on that one?
No.
All right. This, sine of pi over 2 plus 3 pi. Do you get if I add 2 pi, it would be pretty much irrelevant? Because when I add 2 pi, I just go all the way around the circle the whole time, and I'm still where I was. So if I was finding, here's pi over 2. Pi over 2 is right here. And then they add this plus, if they add plus 2 pi, that means I'd go all the way around and I'd be exact spot I was at before. So adding 2 pi would be irrelevant. But adding 3 pi does matter. Because the first time you went all the way around the circle, that's the 2 pi, that didn't matter. But if there's an extra pi left over, then I'm really adding plus a pi. Do you get that? Because the 2 pi part of it won't matter. So you could rewrite this as 3 pi is just like 2 pi plus a pi, and the 2 pi doesn't matter, but the pi does. What is a half of a pi plus a whole pi? 1.5 pi's, otherwise known as 3 pi over 2. And then, instead of being here where I started at pi over 2, I'm now going to 3 pi over 2. So that's another pi, which goes this far, around. And so that's where 3 pi over 2 is, right here. So now if I want to know sine of that, I have to know what point it is. The point is at 0, -1. What part's the sine? the y. Sine y. Remember that. So it's -1. So the answer is -1. Remember, that's a ratio. This is the angle. This is a side ratio, so I could put over 1 if I wanted to. All right. This is number 4 off of last night's homework. And I want to just talk to you about it a little bit. They were saying a 5 and a 13 are related to, think about it, sine. Isn't sine the y? Do you get how if sine is the y part, they gave you sine? They effectively said sine of theta is -5/13. So if you wanted to, you could just run with that then. If sine of theta is -5/13, what's cosine and tangent of theta? Do you get that? It's just like one of those 6-part questions. And I just have to draw myself a little triangle. I happen to have one right here. And if I know that the two sides are 5 and 13, that should be a flag for you like, oh, wait a minute, the 5 and the 13 and the 12, they all go together. 5, 12, 13 is a triangle. You should memorize it just like you memorize 3, 4, 5 triangle. 5, 12, 13. So sine is opposite over hypotenuse, -5 over 13. See, it's all setting up. Makes sense? All right, so now I've got all my sides, and I just have to figure out what cosine of this is. Cosine of this angle right here, cosine is adjacent over hypotenuse, so it would be 12 over 13. And tangent of this little angle right here, tangent is opposite over adjacent, which is -5 over 12. So it all, yes?
When it's like blank, -5/13.
Yep.
Doesn't that mean that you don't know the x, but the y is -5/13? So should
Yep.
the length just be -5/13?
You're right that the ratio is 5/13. How long this side is actually 5/13. But the ratios will stay the same. The easiest way is if you don't even use the triangle, because I think it'll just confuse you. Do you get that this is the y part? Do you get that sine is the y part? So then do you get that sine of the angle has to be -5/13? Okay, and as soon as I've got that, I know that my sides have to be in that ratio. This is a ratio. They could actually be 50 over 130. It's just when you divide it down, that's the ratio that you get when it's done. All right, so once I know that, they're basically telling me one of these and asking me to figure out the other side, and if I know it's 5 and 13, the other side must be 12. Okay. All right. Homework is a lot of word problems. Does that mean they're incredibly hard? No. Mostly they give you like an equation, tell you what to stick in the equation, and it makes it sound really hard, but it's not. Okay? One of the first questions is this one, where they ask you, this is problem 49 off your homework, they're going to ask you sine of pi over 6 plus 4900 pi. Why do you think I can just cross out the 4900 pi? Because it's a lot like a whole bunch of 2 pi's, right? And if I go around 2 pi, it doesn't do anything. If I go around another 2 pi, I'm just going around the circle again. Doesn't do anything. So if this is an even number, you cross it off. What if it was an odd number? Because it is later. Yeah, what if this had been like 3 pi plus 3 pi? Then you'd say, well, the 2 pi part doesn't matter, but there's still a pi left. You get that? You'll always have a pi left over if it's an odd number there. So then I'd have to actually add pi over 6 plus 5. That's like 30 degrees. That's like 180 degrees. So this would make more sense to me if I did it in degrees. It'd be sine of 210. And that is something I could do. I find 210, it's like this. That's not quite that far, but anyway, something like that. And then I go, all right, if that's 210. Oh, wait, 210's not there. Oopsie. Sine of 210 is around there, like that. And then this would be like 30 to make a total of 210. And so this angle must be 30. And that's not what I want, though. I want the side ratios. And if that's a 30, this is a 1. And this is a 2. And this is the square root of 3. And the sine of that is opposite over hypotenuse. Don't forget these are That's not negative. Hypotenuse can't be negative. Sine is opposite over hypotenuse. Sine is -1 over 2. Answer is -1/2. All right. The point here is that when you have some big number of pi's, if they give you 5,421 pi's, all that really mattered was the 1 pi at the end, because all the even number of pi's would just cancel out. Okay, so you go, oh, well, that's like adding 1 pi. Add 1 pi to this, figure out what the total is, and find sine of that. All right, next thing, this one. This is problem number 50. 1, 2, 3, 4, 5, 6, 7 pi minus tangent of 7, 6, 5, 4, 3, 2, 1 pi. The point is, it's an odd number of pi's, right? So what's that like? 1 pi. Odd number of pi's, it's like 1 pi. Do you get now I have tangent of pi minus tangent of pi? Even if I don't know what tangent of pi is, if I'm taking tangent of pi minus tangent of pi, it's minusing itself, right? What's the answer got to be? 0. Good. All right. In your first homework question, that's a word problem, like a serious word problem, is this one. And it's about light refracting. Do you get how light comes in, and then when it's going through the piece of glass, like this is the layer of glass here, it's really thick glass, that it bounces off something? Did that in science or something? Cool. All right. So when the light refracts through that these angles are, angles of refraction. They call them theta 1 and theta 2, 86 and 83. There's this little formula here. Did you learn the formula too? Is that what's called? Cool. All right. Do you guys know what this variable is called? Mu. Very good. Okay. All they're asking you to do is figure out mu. Well, they tell me sine of theta 1, and theta 1's right here, so just plug it in, find mu. It's really not that complicated, but it looks complicated. So if you can just find the formula they're trying to get you to use, figure out what you can stick in where, this one can go in here and that one can go in there, it's really pretty easy. All right. That tells you this refraction constant. All right. So there's kind of a summary of what you have to know how to do for today. You got about 12 minutes left. What I want you to do is grab a book and get started. They're right over there. The assignment is, I'll write it on here for in case you're absent today and you're listening to the video. It is page 382. Leave a cell phone or a shoe as you grab the book. Go ahead and grab them. 49, 50, 55, 59, 61 through 66, 68, and 70.